Hi there, this is quite a short film. It's about how we name covalent compounds, and hopefully you've watched the covalent compounds intro. You may already have watched covalent electron dots 1 and 2, but they're not really that important to watch before you come to this one. So in this film, you'll hopefully learn how we use prefixes in order to denote how many of each type of atom there are in a covalent compound, or how many there is, and how many there are. Anyway, and to know some exceptions that don't use this naming system. Okay, so here we go. Here are the prefixes. Okay, now I've separated them into two groups because these ones I guess people often have to learn from scratch. Mono means one, di stands for two, tri stands for three. This is one that often gets people. Tetra, 4. People often forget that one. And pent. Pent is actually the start of this next group, I suppose you could say, because from here on in, pentagon, hexagon, heptagon, octagon, nonagon, decagon, you may well have used those prefixes in maths when you're talking about shapes. You may even have heard of them in Olympic events like the pentathlon or the heptathlon or even the decathlon. But anyway, there they are. They're important to remember because if you obviously if you don't know how to turn the numbers into names, you'll get the names of covalent compounds wrong, and if you're given a name of something, then you'll get its formula wrong if you don't know how to turn the name into a number. So learn those. They're important. Okay, they were important in year 11 and year 12. Anyway, here's a few examples of molecules that use those prefixes. We've got, first of all, we've got carbon here joined to oxygen, but there's two oxygens, so this one has the name carbon and dioxide. Okay, ide means just that element attached to it. Okay, so oxide means carbon with just oxygen, but the di tells us that there's two oxygens. Here we've got two nitrogens joined to four oxygens, so dinitrogen, and then the prefix for 4, tetra, but the and the o of oxide joined together to make tetroxide. Okay, so see how this is different to the naming of ionic compounds. There you just said what you saw, you just said the names of the ions. In this one you actually have to say how many of each atom there are. Okay, so notice again, all non-metals here, so that's how we'd spot in the test that they were covalent, and they use the covalent naming rules, not ionic ones. Here we've got phosphorus. Phosphorus joined to 3 chlorines. So tri, it would be chlorine, but because we're joined to the chlorine, it's chloride. Okay? Here we've got just one oxygen combined with carbon. So instead of being its relatively harmless carbon dioxide, we've now got a very poisonous oxide of carbon, carbon monoxide. So mon meaning just the one oxygen. And here's one that might be familiar to you. We could call this dihydrogen, because there's two hydrogen atoms, joined to one oxygen, monoxide. You could call it that. There's nothing wrong with calling it that. It's just that no one in everyday life, well, not no one, but lots of people wouldn't know what you were talking about. So we have a more common name for dihydrogen monoxide, and that's water. And this next slide deals with a few exceptions. That is to say, substances that don't follow the covalent naming system, because they've kind of been around for so long that people have got common names for them. So for example, HCl is often called hydrochloric acid, HNO3 nitric acid, and H2SO4 sulfuric acid. You've also got vinegar, or ethanoic acid to be more precise. Okay, so they're all covalent substances. You can have a look at the ion list, and there's a list of all the covalent ones that you need to be able to remember. So make sure you know these things, right? There's no real way of learning them other than just by sitting down and memorizing them, I suppose, unless you've come into contact with them before. Water, H2O, obviously, methane, CH4, and ammonia, NH3. So there's a collection of common examples that you'll see, common exceptions to the rule. They don't use this prefix system just because they've been around for so long, and we've got in the habit of not using it. Anyway, there's nothing else really to say about the naming of covalent compounds. So hopefully you've understood it. If not, go back and watch some of it again and make sure that your notes are nice and clear.